I probably will refer to it back and forth. Talking about data. Caleb Fisher, what is data?
Data is recording.
Data makes the world go on. What did you say data is what?
It's the results of the
Data is the plural of what? What's the singular of data? I think it's data, isn't it? Data. Let me see if I can pull this up on my thing here. Let's quickly start it up. So I can do this with you. We are going to look at, I don't think we did this. Did we talk about how many siblings we have?
Yeah.
Oh, well, then I don't want to do that again. What else can we do? Let's do shoe size.
Shoe size.
Shoe size.
I want to see my shoe size 40 in Europe.
Okay. Let's just laugh. Okay, so here is our little, we've talked about, well, first of all, back to the word data. Okay, data is just information. Okay, but data, until it is organized, is kind of useless information, and that's what we're talking about, making frequency tables and all that. We're trying to collect data and put it into some sort of usable order. It'd be a lot like, you know, if I just gave you your grades, and you know, just like all of them all scattered all over the place, you really wouldn't know what your grade is, because somehow with all that you'd have to figure out your average, which means you'd have to put it all together, divide by whatever. So data by itself needs to be put in some sort of organized way, and that's what we're going to talk about here. We're going to make a frequency table, and we'll call it shoe size. Maybe that's just because maybe I want to open a shoe store, and I want to know what sizes to carry more of. Now, to do that, I suppose we'd have to, before we jot some stuff down there, I suppose we need to know who's got the smallest shoe size in here. What do we got for shoes? Who's got a small one? Zach, what's yours?
2.5.
2.5. Joseph?
3 youth.
Let's just give you the numbers, 2 and 3. Okay, so I'm going to start with, and we're going to do this because sometimes you don't want like a whole bunch of different numbers here. We'll do the 2s and the 3s, and then we'll go the 4s and the 5s. We'll go the 6s and the 7s, the 8s and the 9s. I don't know, has anybody get up to the 10s yet? Any 10 or 11s? And not anything above 11 in here? No. Okay, so these are our different increments. You know, we're not going to get into the halves or whatever just because there'd be way too many, but we're going to do that here. And we're just going to, when I ask you, just tell me if you don't know. I guess take your best guess. I don't know, you have some idea. Look at your shoe, and maybe it has a size on it somewhere. Usually on the tongue, if you look at the tongue, it says, or there's a little round thing on the bottom of your shoe that says, Madison says, what's it say?
I'm between the 7 and 8.
Well, that would put you at the, we'll round up or down, I don't care. You pick one. I don't want halves, just give me a number that's close to what your thing is there. So let's just start here. Aaron? So Aaron says 9. So we put a tally mark at 9 because that's how we're going to keep track. Brian?
About a 9.
About a 9. Riley, what do you think? About a 5? Wait, Grace, what? 3? The 3s? 3 start putting down? 4? By the way, if I ask you this next year, I'll bet you'll go up like a whole size and a half. John? 7. Zach, you said it's 3, 2.5, whatever. Maya? 7. Connor? 8. Lauren? 7. Madison, you said, I thought we were going 8. Did you say between 7 and an 8?
Yeah, but
You don't want the 8? I'll give you 7 just because. Joseph?
3.
3. Boom. Caleb?
9.
9. Ella?
5.
5. Boom. Ellie? 3. Right there. Matt?
7.
7. Oh, look at that. We're getting all there. Autumn?
8.
8. Got some forerunners. Are late.
7.
7. Back there. Sir Grace?
5.
5. Oh, this is pretty evenly spread out here. Jacob?
8.
8. 1 right there, yeah. And Sophia?
5.
5. And you know what? Just to make fun, I'm going to tell you mine. I'm at 11. Is that everybody? Get everybody? So those are the tally marks. We're organizing our data. We write down the frequency is how often it happens. So how many 2s to 3s? We had a 4. How many 4s to 5s? We had 5 of them. 6 to 7s, there was a 6. 8 to 9s, we had 6. And 10 to 11s, we just had 1. Now, like I said, if I was opening a shoe store, that would kind of be some good data for us, especially if I was going to sell only to 5th graders. I call it my 5th grade shoe store. You know, I would know to carry a whole bunch more probably of these than I would of 10 to 11s. And maybe, you know, that's actually a pretty big grouping there. Now, in order to show that, all right, we are going to make what's called a histogram. Have we done histogram? No. If I can find my paper for histogram. Yes. No, yes. Hold on a second. No, yes. Let me make sure I put that one here. Yeah, we'll make it on this one. No, that's a pictobar graph. We'll just use the line graph here. This one right here. Cross off the word line graph on top of that and then mark over top of it histograph. What you do in history for making a graph out of it. Okay, what your histograph is, you're pretty familiar with a bar graph. Well, a histograph, again, I will find another, let me find it on my sheet here. Lesson, what's that say on top of that? 31? 31. Let me snag one here so I got one too. So I got one too. I'll leave you out in the dock. Okay, our histograph, make it a little bit bigger. It looks like this. Okay, I said cross this off. Let's call this a histograph. And really the thing that makes a histograph different than a bar graph, okay, it is a bar graph with no spaces between the bars. And you really use it to kind of show comparison. So here, let's throw our labels down. What was our graph going to be about? 5th grade shoe sizes. Alright? And this, guess what this label is here? Joseph!
The numbers?
Well, there will be a number, but you got to be kind of specific about this one. Grace?
The size?
This is not actually the size. Now, let me go back to the screen here. A histograph actually takes this table and turns it completely sideways. So on my histograph, I'm going to have a bar that only goes up 1, goes up 6, goes up 6, goes up 5, goes up 4. These shoe sizes actually end up being the numbers on the bottom. Okay, so I'll write that down. Shoe size. And you are looking at, okay, we're making bars here. What was our first shoe size? It was a 3 to 4, right?
2 to 3.
Sorry. It was a 2 to 3. then the next one was a 4 to 5, and then a 6 to 7, and an 8 to a 9, and a 10 to 11. You don't need those other two columns. So that's a shoe size. So back to my question, okay, and this is going to be 1, 2, 3, 4, 5, 6, 7. What do we label this side? Caleb?
How many downers?
What's that?
How many downers?
Okay, but there's a name for that. Let me go back to that.
Frequency?
Yeah. This side is actually labeled, and I'm going to do my best. Watch this sideways writing. Frequency, or how often, or how many you get. Frequency. Okay, and then I'm going to change colors just because I can. I don't know if I want to make them blue. Sure, let's make them blue. No, let's make them orange.
Yeah.
So here's what it would look like. Again, this is like having bars with no space in between it. How many people had the 2 to 3s?
4.
4. So you're going to color in. And if you had colors, it'd be nice. Or you can just kind of shade them with your little pencil, I guess. But what fun is that? So I know that here is in the 2 to 3 range. We had 4 people that had size 2 to 3. How many people had the 4 to 5s? 5. So we go all the way up to 5. Now notice again, there's no gap between my bars. They come right together there. I should maybe do a wider thing so I don't have to color quite so much. How many 6 to 7s?
6.
Well, there's 6, so that one goes up to 6 right here. How many 8s to 9s? Is there 6 again of those? Pretty consistent, y'all are. It'd be interesting to compare ours to 7th grades and see what their shoe size is. And then there was one lonely 11 by somebody in here who shall remain nameless. Okay. And this, boys and girls and kids of all ages, is your histograph. Looks a lot like a bar graph, but remember bar graphs have spaces between them. Okay. It's a good way to look and see kind of change, and most people are in a good number of them are in the 6 to 9 range. I actually got some good 2 to 3 ones there as well. Good for that, good for you, good for everybody. Perfect. Okay, now we need to forge ahead because we're not only talking about that. And again, that is organized data in some sort of way. Now, you still have a blank piece of paper?
Yes.
If not, take one out because we are going to talk about something that's called a stem and leaf plot. A stem and leaf plot. I gotta see what we're gonna stem and leaf about here. Well, the book uses, tell you what, look at page 451 with me, please. For lack of anything better, we're going to talk about the weight of turkeys.
Yay.
I don't know why. The weight of turkeys. So write these numbers down in yours as I write them on mine. We're only going to do the bottom row here. 19 pounds, that's a pretty big turkey. 13, 14, 22, 19, 22, 18, 20, 12, 25, and 23. I didn't want to do all of them because it would just take a little too long, and I think you'll get the point with this. A stem and leaf plot, okay, is basically this. The first thing to remember is the leaf is always the last digit. And the stem are any digits in front of the last digit. Any digits in front of last digit. And it'll make maybe more sense once you see it. And you always start a stem and leaf plot a little like this. We have a little line. On the left side of the little line is the stem. It's almost like a tree. On the right side is the leaf. And you can think about this a little like separating them in their groups of tens, especially on this one, okay? If we look at how many different numbers do we have for stems? Okay, the leaf is the 9, the stem is the 1. The leaf is the 3, the stem is the 1. 4, 1. 2 is the leaf, 2 is the stem, 9 is the leaf, 1 is the stem. What are my different stems? How many different stems do I have? If you look at all those numbers, I just have what? How many different ones, Lauren? Right. And my stem, I'm going to have a 1 and a 2. And the 1 really stands for all the numbers that fall in the tens place. It would be between 10 and 20, and 2 is all the numbers that fall between 20 and 30. And here's how you organize it. Okay, my first one is 19. Well, this is the 1. The 9 goes in this part over here, and you try to do it in order. In other words, 9 is about as big as you're going to get for a leaf, so the 9 you have to put way over here because you got to leave room in case you have 8, 7, 6, 5, 4, 3, 2s, and 1s over here. So the number 19 would be made with the 1 and the 9. 13 is a 1 and a 3. This whole thing over here is the leaf, even though my number's right there. I should kind of figure out already, so you don't get confused about what I got going on here. Let me get rid of this. So this doesn't get in the way. You can keep your stuff. Sometimes I don't erase hard enough. Okay, so I've got my 13 and I have my 19. I've got a 14, so we would put that probably right next to the 3. 14. 22, here's my stem of a 2 and my leaf of a 2. Another 19, so I have to put a second 9 over here. So I have 2 19s, that one and that one. Another 22, so I put another 2 here. And 18 is a 1 and an 8. A 20, I have to put a 0 here. A 12, okay, there's a 2 there. A 25, so I gotta put a 5 over here. And a 23. So you want to get that? So go on, Caleb.
Is this the next one?
That was the next one.
Oh, that's right. That's what it was.
So hopefully you can see this. You know the numbers we have. 1, 12, 13, 14, 18, 19, 19, 20, 22, 23, 20, 22, 22, 23, 25. Another way to organize those numbers so you can kind of see, you know, as the groupings where they belong. Let me see what else they do with it. Use information stuff. And if you notice, well, no. Okay, it's just, like I said, just a different way to kind of organize your numbers and get them put in rows and orders so that you can see. Anything that you can come up with about this? Are there more numbers in the tens place or the twenties place or which one? Caleb?
Can I stem go up to 3?
Yeah, if I would've had a 35, I would put a 3 here and a 5 there. Okay, you could do, what if a number was 106? I gotta do a little movement here. If it was 106, let's see if I can do this. If it was 106, the rule still applies, the last digit is the leaf, whatever comes in front is the stem, so you'd have to put a 10 over here, and the 6 would just go over there. 106, because that's 10 tens. 1 10, 2 10s, 3 10s, 10 tens. So there's always only one digit here, and whatever else would fall in front of that stem there. It's kind of just a way to organize all of those numbers there. I don't think they asked us to do anything else with it. No, maybe not. Maybe not. Yeah, perfect. Well, we're gonna stop at that part, but we are gonna